So today we are looking at earth geometry. This is a paper 2 question. Also in paper 1 it comes with about 2 marks, then paper 2 with a good marks about 5, and paper 2 is optional, but make sure I encourage you to choose this question. So this is the globe. As you can see, we know the compass direction: north, east, south, west, right? So are you seeing these lines which are like horizontally lying? These ones, these are called latitudes. See, the middle one is the equator. So latitudes can be north or south of the equator. Even the equator itself, it is also a latitude as well, right? So these are latitudes. Then are you seeing these lines which look like they are in a vertical way? These are what we call longitudes. These ones, they lie whether on the eastern part or western part of the prime meridian. Prime meridian is also like the center of the earth in a vertical way, right? You also call this line Greenwich because it is passing through a place in London called Greenwich. You see that? So it divides east and west, and the equator divides north and south, right? So whenever you're talking about longitude, it means you're talking about east or western direction. And whenever you're talking about latitudes, it means it is either on the northern part or southern part of the equator. We know equator is 0 degrees, right? Okay. We move on. Now we need to know the concepts. Earth geometry, make sure you know the concepts for you to be able to solve questions. So here, time calculation concept. We use these scales, like 1 hour is equal to 15 degrees, and like a smaller scale is 4 minutes is equal to 1 degree. Now take note that when going eastwards, time gains. When going towards the east, like in this case, if you are going towards the east, you will be ahead in time, and if you are going towards the west, you will be behind in terms of time. So you need to take note of that, that concept. Then, so for this one, this is why you have been seeing these two concepts. You have been seeing scenarios whereby if there a certain club is playing somewhere, you find that people in Zambia, they are watching that maybe soccer around during awkward times, let's say 22 hours, 21 hours, but maybe that side is not even 21. That side maybe it is around 18, 17 or so. It is because of time differences. So now, any country which is on the eastern part of the other will always be ahead in terms of time, and any country which will be on the western part of the other will always be behind the time. So now, this is where Zambia is, for example. This is Zambia. Towards the eastern part of Zambia, there is China, for example. In reality, yes, that's where China is. And towards the western part of Zambia, there is USA, America, right? So this is Zambia, right? So now, have you seen where Zambia is? Zambia is on the eastern part of USA, so it will always be ahead in terms of time. Have you seen where China is? And have you seen where Zambia is? Zambia is on the western part of China. It will always be behind the time, and China will be ahead in terms of time. For example, I'm sure you must have a world clock on your smartphones where you can easily have those towns, right? So for example, when it is, you'll find that when in Zambia when it is 00, in Zambia when it is 00, Zambia Lusaka 00:29 as the time. New York will be what time? Behind the time. It will be around 18:29, about 6 hours difference. You see that? Us we are ahead. You see, us is midnight, almost midnight, past midnight, but them is not yet, right? Now, what could be time in China, Beijing? The time could be 06:29. Have you seen that? So China is ahead of us because China is on the eastern part of Zambia and Zambia is on the western part of China. If we were to put this map, right? You see, China is on the eastern part of Zambia, it always be ahead in time. Zambia is on the western part of China, it always be behind in terms of time. So you see, us is 00:29. You find that them it is 06:29 already. They are now preparing to go for work. Whilst in Zambia, this is when now they are snoring. So this is how time calculation is regarding China or these areas, time differences. So now when it comes to difference in degrees, you're going to see how they are going to be asking us and how we'll be able to use the difference in degrees to find the time and distance. So you should be aware that when 2 points are on the same locations, let's say they're on the north and also south or maybe east or maybe west, the difference in degrees means you should subtract those. So we say same locations, subtract, right? Different locations like north, south, or maybe they're on the eastern part and western part, you add those degrees. This is how we're able to find the difference in degrees. Then we have the speed. When distance is in kilometers, speed will be measured in kilometer per hour. We are aware of this. But now when distance is in nautical miles, abbreviated as nm, the speed will be measured in knots. This is why if you see paper 1, they'll say find the speed in knots. Just know that the distance is in nautical miles. Nautical miles, these are units. They are usually used when traveling on the sea or ocean, and also by air. They like using nautical miles instead of kilometers, right? So now we know this table. Speed is equal to distance over time. For you to know speed, you just do this. It means divide distance over time. If you want to know time, divide the speed over, if you want time, divide distance over speed. If you want distance, it means you have speed times time, right? So these are the concepts that you're supposed to know. So now, what about finding the position of a point or the location of a point on the globe? You see, how can you do it? So first of all, always write the latitude. For example, latitude, it means it can be north or south. So write the latitude north or south first, then the longitude east or west later on. For example, look at this. So we have point Q in this case has, or the position is 20 degrees north, 40 degrees east. Don't do vice versa. Don't do vice versa. For example, what is the position of point M? The position of point M will be, which one is your latitude? Is this one with N, right? North. So it's 55 degrees north, this longitude is 30 degrees east, right? So you say 55 degrees north, 30 degrees east. This is the position of point M. If it is Z, the position will be 65 degrees south, 45 degrees west. That's how you are able to find the position of a point or the location. Now, we need to know how to find distance. So, distance along the same latitude, use this formula. Theta represents an angle, theta over 360 times 2 pi r cos x degrees. Even x also will be putting an angle, right? So same latitude, for example, if you want to find from Z to R, the distance from Z to R, as you can see here, do we have such a, question 4. Find the distance ZR in kilometers along the same latitude. So you need to use this formula when 2 points are on the same latitude. Then distance along the same longitude. Have you seen this formula and this one? Only cos x degrees is missing, right? You write the same but remove cos x degrees. It will mean the formula under same longitude when the points are on the same longitude. That's the difference. Or we can also use 1 degree is equal to 60 nautical miles when radius r is in nautical miles, right? So when radius r is in nautical miles, use this formula as well to find distance along the same longitude. Let's see if we have any question. We have this one. You see, radius was given in nautical miles, 3,437 nautical miles, nm, right? Then read question 3. It says find the distance AD from A to D in nautical miles. So from A to D, they are on the same longitude. So we need to use, we can use any of these formulae, whether this one or this simple one, right? Then finally, we must also know how to find the circumference, which is C of a circle. Circumference of a circle, you know, circumference is the perimeter of a circle, the distance around a circle, right? So you use this formula, 2 pi r cos x degrees. Now, are you able to see that this formula is also part of this? Look at this, 2 pi r cos x degrees, same here. So these are the concepts that you have to know. So in the next video, we'll look at examples now so that we see how we can utilize these concepts to solve a question.